We continue moving forward with more area problems, which means more area formulas to know. Yay! The first formula deals with trapezoids. So here's a quick reminder about trapezoids. A trapezoid is a quadrilateral with two parallel sides. Those parallel sides are always the bases. Even if the trapezoid is on its side like this one, the parallel sides are still the bases. The bases don't have to be down or on the bottom. I make a point of this because the formula for the area of trapezoid uses bases. So you have to be able to identify which two sides of the trapezoid really are the bases. The area of a trapezoid is equal to the average of the bases times the height. Just like the last section, make sure you know where to find the height. This one is still not the height. This formula can be written a few different ways. This is one common way, since it's a mathematical representation of average of the bases times the height. But this is also a very popular way to write the formula. If you prefer that one, go ahead and use it. Use whichever one you're most comfortable with. Just to give a quick example of it in action, here is a trapezoid with the measurements filled in. We plug those values into the equation, take the average of the bases, and then multiply it out. This trapezoid has an area of 684 units squared. The next formula is used for both rhombuses and kites. It works on either shape. When we did special properties of rhombuses and kites, their diagonals played a large role. And what do you know? The diagonals are key to their area formula also. In the formula, D1 and D2 refer to the lengths of the whole diagonal. I'll show you a quick example to make sure you avoid a common mistake. Here I have a rhombus, and it tells us its perimeter is 40 meters with one diagonal of length 12 meters. Since we are dealing with a rhombus, and the formula for the area of a rhombus deals with the diagonals, it seems to make sense that we would draw the diagonals, right? You should remember this from earlier, but the diagonals of a rhombus are perpendicular. This is going to form right triangles, which are often used when dealing with problems involving a rhombus. We know that a perimeter of the rhombus is 40 meters. Hopefully you remember that a rhombus is equilateral, that is, all sides equal, so each of these sides is 10. We also know one diagonal is 12 meters, so we can fill in these two values. Now we have one diagonal, but to use our formula, we need the other diagonal. As I alluded to earlier, right triangles are often going to come into play. So here we will want to use the Pythagorean theorem to find the missing side. I won't go into the details, but that Pythagorean calculation should get you these two values. Now here is where a lot of students make a mistake. The formula uses diagonals, and we have work to fill in those values. So it is common for students to say that the area is 1/2 6 times 8, but that isn't right. Don't do that. The formula is for the full diagonals. 6 and 8 are only half of the diagonals. You should be getting 1/2 times 12 times 16. That is the correct way to do it. D1 and D2 are the full diagonal lengths, not half the diagonals. The same error happens with kites too. Now just multiply it out so you get a final answer of 96 units squared.